Okay, let's begin with this question. Okay, let's read and say. Okay, consider the ending series. Have weird, not so weird, I mean, unique naming ending series. Okay, so they have this 2, 5, 6 plus 1, 2, 8 like that, plus 64, blah, 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 32 until they say 0.25. So one of the ways to figure out what type of series is this, because you only learn two types of series. One is the arithmetic sequence and the other is the geometric sequence. So if you minus, you can see a fixed difference that would be an arithmetic sequence, but such is not the case here. As you can see that the common ratio, that is you take the second term, let's say divided by the first, 1 to 8 over 2, 5, 6, or whether the next one, you could have taken 64 over 1 to 8, or could have just taken 32 over 64, any one of the given pairs, but all of that would give the same value or ratio of R, which is half. That means the constant R equal to half is the constant here. That means R is the common ratio. So the common ratio part tells me, so here they didn't tell what type of sequence. We had to figure out the common ratio is half, means a common ratio being fixed means this is a geometric progression or geometric series, in fact, because the reason why I use the word series is whenever the addition is used. So when you see a plus sign, you call it a series. Put a comma, you can call it a progression or a sequence, okay, of the same numbers. Aha. So a geometric series has two parameters. So one is the common ratio, and the other one is the first term. So when we talk about the first term, in this instance, it's 2, 5, 6, the first one. Oh, so now we understand the A and R. So we actually already done the 4.2.1 part, which is asking give the value of A and R. And hence Tn. Tn is the general, what we say, representation of the nth term. So generally we use the formula for the geometric series would be AR to the power of n minus 1. Okay, just substitute only. So just making it case specific, you can say it like that. So 2, 5, 6 times R is what? Half to the power of n minus 1. So it's a clever way that we need to manipulate the numbers here because good recognition of numbers is needed. So 2 to the power of 8, 2, 5, 6 is 2 to the power of 8. So by that kind of observation, we can simplify this further, making the base same. Aha, so 2 to the power of n minus 1 like that. So it's one in the numerator and one in the denominator. What must we do? We must take the numerator power, that means the 8 at the top, subtract the power in the denominator. Okay, just like a shortcut. So that means when you open up the brackets, this should be 8 minus n plus 1. It's all simple for advanced students to calculate this. So 2 to the power of 8 plus 1 should be 9. So 2 to the power of 9 minus n. When I put a bracket or without a bracket, it's still correct. Okay, so that's how we get the general expression of the nth term. It's 2 to the power of 9 minus n in this case. Okay, let's go for the second part here, 4.2.2. They say calculate n, the number of terms in the series. So using this, 2 to the power of 9 minus n, now assuming that the n is representing the total number of terms of the series, that means it must equal to the last term, that is 0.25. So 0.25, again, you put in the calculator, or you can immediately see is 1 over 4. So 1 over 2 square. As much as possible, we want to equate it to the exponent 2, which would be possible by the given numbers. So this is just 2 to the power of negative 2, actually. Aha. So we equate the index, talking about these two parts. So if we equate the index, then we should see that 9 minus n equals to negative 2. Just rewrite to solve. So n equals to 9 plus 2, or finally, n equals to 11 terms. Aha. So that's how we figure out the second part using the formula approach. Now, the other one you can just list out and manually count because they only 11 terms. But that's not advised. As much as possible, you must use the formulas given. That's the idea of the exams. So 4.2.3, let's read that. So hence determine the sum of the ending series. So basically now, since we know Hence means must use the earlier value or earlier values. So in this case, we have 11 terms. So we just want to calculate S11. So to calculate S11, we just need to know the formula for the sum of the first n terms of a geometric series. Just to recap back, AR to the power of, what is the formula? So I use the other version because R is less than 1. That means 1 minus R to the power of n over 1 minus R. So let's use this substitution correctly in this line with the n being replaced as, so I just write the parameters somewhere here. So easy to see, n is 11, A is equals to 256. So R is equals to half. So that means just substitute only. So this is 256 and 1 minus 1 over 2 to the power of 11. And then here, 1 minus 1 over 2. So when you flip it upside down, that means 256, 1 minus half is just half. So it becomes times 2 like that. So in the bracket here, this becomes 1 over 2 to the power of 11. Notice I didn't multiply out. There's a reason why. Because I'm just going to do a bit of a trick here to simplify my calculation manually. Please take note, 256 from the earlier line also is 2 to the power of 8, right? So this is 2 to the power of 8 times 2, and then 1 minus 1 over 2 to the power of 11. You can just put the whole thing in the calculator, but if you just want to play around with the algebra a little bit, you can put it like that. Then you can do 2 to the power of 9. When you minus 2 to the power of 9 minus 11. So all these are just the same thing. Okay. So I'm just going to leave it at this. So this becomes 1 over 2 to the power of 2 like that in the negative. So I put it like that. So all in all, the answer becomes, let's put in the calculator because it gives a calculator available for exam at this level. So 2 to the power of 9 times 5. If I'm lazy, I just put back that line. 1 minus 1 divided by 2 to the power of 11. So if my calculations are all correct, the answer should be 511.75. Of course, you can use a decimal answer or a fraction or mixed number accordingly, but I prefer decimal whenever the decimal is ending. So it's easier bit. Okay. All right. Thank you.